Tonight, it's our pleasure to be joined by our colleagues in the USDA FAPRU unit. We've got Dr. Michael Flythe and Dr. Brittany Harlow joining us this evening. It's a great relationship. It's really nice to have a USDA group on campus. There's a lot of interaction that goes on with the research teams and exchanging of ideas, and we can tend to make more progress together that way than trying to do things on our own. And so we're joined by our two colleagues this evening. They're going to share with you a little bit about some of the things that they've been working on. And I think it's also important that we recognize there's some great facility development, I believe, Dr. Flythe, coming up too. And you can expand on that later if you'd like, or we can save that for another day. But at this time, I'm going to go ahead and introduce Dr. Flythe. Dr. Flythe received a PhD in microbiology from Cornell University. Since that time, he's been a researcher, and he has specialized in kind of the rumen microbiology area. He's been with the USDA ARS Forage-Animal Production Research Unit, which is FAPRU that I mentioned earlier. And Michael started in a position where he's been the research leader after Dr. Glenn Aiken retired since 2019. He is also an adjunct in our department and serves on several graduate student committees and helps mentor those students along in their training as well. So with that, Dr. Flythe, I'm going to turn the program over to you, and feel free to share your screen.
Thank you, Dr. Lemkuehler. It means a lot to us to be here with you tonight. I got to admit, I'm impressed by the number of folks who show up this time of the evening to come to a seminar like this, a research seminar. But these events mean a lot to us. We're full-time researchers at FAPRU, and which is a great thing to be able to do. But it doesn't mean anything without the work that the extension specialists do and the county agents and the teachers to get the word out about that research. And then on the other side, you got to have cattlemen that are willing to show up at 8 o'clock at night to a seminar. And it means a lot to see everybody here tonight. So I had the easy work tonight because Dr. Brittany Harlow is with us here too, and she's going to do the heavy lifting. She's going to show some data. She's going to really get into some experiments and show you all what we've been working on. And so my job here really is just to set up Brittany and kind of provide some of the background information that you'll need to be able to get your teeth into her talk. And it also gives me an opportunity just to kind of talk about, why we do what we do and why we think it's important, which, to be honest, helps me even more than it helps you to be able to look at some of the big picture stuff here and be able to talk about it with folks. But since Jeff mentioned it, yes, we do have a building project on campus that's moving forward. That's exciting. We're building a research facility on the south side of campus, right across from Kroger Field, right on University. And it's going to be a research laboratory for 20 investigators, and 6 of them are going to be USDA, and the rest are going to be University of Kentucky investigators. And the idea is that, we work with all these wonderful folks at University of Kentucky, and the more of them we can get in one place, get them together, get them, as I put it, sharing a coffee pot and working on the same things and talking about the same things, that it'll be good for the research and it'll be good for Kentucky agriculture. And so that's exciting. The timeline on that goes out to probably 2026 or 2027 before we get that building built, but it's going to be really great. So to jump into this here, oops. Make sure this is going to advance. So as Dr. Lemkuehler said, my background is really in microbiology. My graduate advisor was a dairyman and a rumen microbiologist, and so he really introduced me to agriculture. But in a lot of ways, my education began when I came here, and I started meeting folks. I started having lunch with the forage specialists in plant science, and started working with the researchers in the ag college here, and really started thinking about the big picture, because researchers don't always think about the big picture. We get into a little thing that we're into, and become an expert in that and learn as much as we can about that. But to step back and think about the whole system is really valuable. And so I thought I'd share some ideas related to that with you tonight. So this is how I've come to think about our production system in terms of our values. And so I've come to call this my triangle of respect. Why we do what we do, and how are our values reflected in our production systems. And so this triangle of respect through three corners, right? First, you have to respect the people who are doing the work. The people who are going to raise animals on forage, who are going to raise cattle or other animals on forage, they're doing it to make a living, and they have a lifestyle, and you have to respect them. So any production system we have has to respect the people. The animals is the other one. And so animal welfare is incredibly important to us. When an animal is healthy and it is performing well, a productive animal is going to be a profitable animal. And so we really believe that these things go together. You have to respect the people, you have to respect the animals. And the other thing you have to respect is the land and natural resources. Are you going to be able to keep doing the kind of farming that you're doing there forever? Or is it going to cause erosion? Are you going to have problems with groundwater? So anything we do, anything that we're going to put time and federal dollars into, we're going to look at it through the lens of our values. And this is what I think our values are right now. So I made this slide originally a couple of years ago, and I've changed my mind about it a little bit to think about, to push into it a little bit. What characteristics do we want in a ruminant production system? And I led off with a light environmental footprint. And that some of my colleagues have convinced me that we can even do better than that we can have a positive environmental footprint. And moving forward, one of the things we're really interested in is this idea of regenerative agriculture, which I know all of you have heard so much about. And I personally think, Brittany thinks, our team believes that the type of agriculture, the type of cattle systems that we do here in Kentucky have something to contribute to that. And we can practice a type of agriculture that really does respect the land and natural resources. But it should minimize risk to human health. Nobody should get hurt doing it. Nobody should get sick in our systems. They should be profitable. If they're not profitable, you're not going to do it. And you have to maximize animal health and animal welfare, because again, that's how you're going to be profitable. So what's loaded in the term respect is understanding. And so that is the role of the researcher here, is to help you in understanding. And it's to find out those things that we don't know. And it's a small part of what you do, but I like to think that it's an important part of what you do. And we've made a lot of advances in American agriculture through the last century that I think back that up. But so this understanding, this is my job. This is Dr. Harlow's job, to try and shed some light on things. And it isn't easy. And so this is a table, maybe you've seen one like this before, and this is how I like to think about problems. You have things that you know, and then things that you don't know. And then there are things that you don't know, and the worst kind of things of all are the things that you don't know. And this comes up, and things surprise you in research. And we have a story I'll tell you about that. But often you ask somebody, and they'll kind of draw a box around this and says, this is what's important. I know what's important. And there are a few things maybe that I don't know that are important too. And I need to find those things out. But then there are a lot of other things, all these things in this other category, and all of them really in the you don't know category, that people will say don't matter. And the word that I love is junk. It's a great word. When you hear the word junk in science, you're about to find a gold mine in things that other people don't think are valuable. So here's some examples. Things that used to be considered junk. Everything in cells except for enzymes, including DNA. They said that none of that stuff mattered. The enzymes were the only thing that mattered. Everything else was junk. After they figured out the DNA was important, they said that all non-coding DNA was junk. And that was a word even when I was in graduate school. They used to hear all the time, oh, junk DNA, it doesn't do anything. We're finding out that a lot of the non-coding DNA might be the fountain of youth. It might be really, really important. Everything in the soil except for water at one point was junk. And then everything in the soil except for water and NP and K were junk, and everything else was really minor, didn't have an important role. We no longer believe that. All the bacteria in your gut are junk. They're not doing anything. They're just commensals. They're just hanging out there, and we're finding out, no, they're really important to your health, actually. I can proudly say that this is one place where animal science was way ahead of human medicine, where in the rumen, we realized really early that those bacteria were important and they were doing something for the animal, even before our colleagues over in the medical college understood that. And this is one that's especially important to us. Everything in food or feed except for protein, sugar, and fat at one point was junk. This is a conversation that Glenn Aiken and I had years ago, going back, before the discovery of the vitamins. And I think we're on one of those precipices again, where we're starting to realize all those things that we didn't know, like right before the discovery of the vitamins. That's what Glenn thought about our research, and I think he was right about that. So I got to bring you up to speed on a few things to get you ready for Brittany's talk. And so plant and fungal secondary metabolites are one of those topics, and they're really important to our research. And they're one of those categories of things that used to be considered junk, and we're finding out they're not. So junk molecules in plants, low concentrations in the plant tissues. There are different secondary metabolites in different plants, and they would include the phenolics or the isoflavones that Brittany's going to talk about. I'll talk about it a little bit too. Tannins, alkaloids, other things. At one point, we didn't think they did very much. They were either poisonous or had little no function at all. And junk molecules, when they're in food too, the same things. They're bitter. They activate the bitter receptors. At least the phenolics do the bitter receptors on your tongue. Sometimes they're poisonous, but we thought they were largely unimportant. And surprise, they're not junk. They actually have functions. And so this is one of these areas that I think for the next few decades, we're really going to be discovering a lot about nutrition that we didn't know. So 2 examples here. They're important to agriculture in our region and important to research at University of Kentucky and FAPRU. Tall fescue and its endophyte there. And I know that most of you, I was scrolling through the names of the folks who are here, and I know I've talked to many of you before, and you've heard us, heard our talks. We've been talking about tall fescue for years now, and its endophyte. And so that's a really close-up view of tall fescue on the left there. Those are the cells, and you can see that that dark blue thread making its way through it is the fungal endophyte, that epicloe endophyte that lives in tall fescue and makes the ergot alkaloids that are toxic to the animals. And on the other hand, we have red and white clovers and some other forage legumes that make isoflavones, including biocannin A. You'll hear Brittany and I use both of those terms kind of interchangeably tonight. Biocannin A is an isoflavone, the way that ergovaline is an ergot alkaloid, but we kind of use the terms interchangeably for these talks. So many of you have probably seen this picture before. It was taken by Dr. Jimmy Klotz. He's a vascular physiologist with FAPRU. And this came from a study that he and Jamie Matthews did in 2006. I think it was the summer of 2006. Classic looking fescue steers. They're all shaggy in the middle of the summer and, covered with mud because they've grown back their winter hair coats and they look crazy. Good picture for a talk, but not what you want to see in your cattle. And so those ergot alkaloids are secondary metabolites that cause fescue toxicosis. The symptoms include decreased prolactin and winter hair coat retention, actually regrowth. Dr. Glenn Aiken did that work. And many of the problems from fescue toxicosis come from vasoconstriction. So the constriction of blood vessels, I'll show you another picture here in a minute of what that looks like. And that causes problems with heat dissipation and nutrient absorption around the gut and reproductive problems too. And so some of you have probably seen this slide that I presented before. This is actually a carotid artery of a goat. And so the red dot right there in the middle of that panel, you have to imagine that you're looking down the blood vessel. And so that ultrasound probe was placed right on its throat. It was shaved and placed on its throat. And so you could get that image and imagine you open a shotgun and look, from the breech and look down the barrel. That's what you're looking at down the carotid of the goat there. And And so that's what a constricted one looks like. And this is what a relaxed one looks like. And so the diameter is just opened up. Imagine opening that pipe up and increasing the blood flow through it or decreasing the blood flow by constriction. And so the alkaloids made by the fungal endophyte in tall fescue are vasoconstrictors. They do what you see there on the left. And the isoflavone metabolites are vasorelaxants. They open up the blood vessels like you see on the right. So it's, long been recognized the toxic tall fescue pastures, if cattle are in them, they just do better. They perform better if there's clover in them. And we've attributed that to dilution. The cattle have something else to select, something else to eat besides toxic tall fescue. So they're not getting as much of those isoflavones. And while that's true, our unit determined that it wasn't all dilution, that there's a vasorelaxation, a vasodilation effect. And just for the sake of Brittany's talk, many of you probably heard this before. It's been, about 8 years ago that we did this, but I'll run through it again with you. This was done with goats, rumen fistulated goats that we did in the basement of Gerges. And it was important that they're rumen fistulated so they can't go off feed, because if you really slug the ergot alkaloids to them, they will go off feed. And but we could dose them with exactly what they needed to get through the rumen fistula. And so we gave them either Kentucky 31 seed or extracted alkaloids, and then red clover extract that was rich in isoflavones, including biocanin A. And then we could measure their the luminal areas of their carotid and their forelimb arteries. Actually, we did the auricular artery on their ear some too. And these are the data. I'm not going to show you much data. Mostly Brittany's going to show you data, but this is all just kind of preliminary for her talk. And so if you imagine, looking at that panel right there, the vertical axis right there where the zero is normal blood vessel diameter of the goat, normal carotid diameter of the goat is what zero should be. And so we started the fescue alkaloids on day 0. And then by day 6, this proportionate difference, you can think of it as percent really. So 25 to 50% constricted. So considerably less blood being able to flow to that animal's head, day 7, day 8, constricted. And then what we did on after day 8 is we continue the fescue alkaloids. They're still getting the alkaloids to constrict them, but we add clover isoflavones into the rumen too. And as days 1, 2, 3, 4, they're still constricted. By 5 and 6, they're going back to baseline. They're opening up again. And then we did kind of a flip experiment from that, where we started them on the fescue alkaloids and the clover at the same time. And so days 1 and 2, they're not constricted. Day 3, 4, they're actually a little bit higher than baseline. They're actually a little bit more open. But what we did after day 4 here is we continue the fescue alkaloids and we stop the clover isoflavones. We stop giving them the clover. And really rapidly, within 2 days, they're constricted. And by day 5, they're very constricted. There's half of the blood flowing to the head of that animal. So very much in fescue toxicosis. And so we did this a couple of different ways, a couple of different times with these goats, and you could open and close their blood vessels like a light switch using these secondary metabolites out of forage. But we really weren't looking for a vasodilator. It was one of those cases of where you don't know what you don't know. Vasodilation was a surprise. We were really looking for antimicrobial compounds from forage plants. And it's why you have to be paying attention when you do these things, because it's ended up being really important. And we hope it's the kind of thing that will help you make decisions about whether or not to include clovers or other legumes or even supplemental feeding of legumes in your systems. We think it's going to be valuable to you. And Brittany has several experiments to show you related to that. But we didn't know what we didn't know. It wasn't what we were looking for. And the antimicrobial effects are also important to her story. So I'm going to kind of run you through the early part of that too. And so they're rumen active. These same compounds that are vasodilators are also antimicrobial in the rumen. And so there's rumen contents from a steer. Actually, I think that might have been that 2006 study, that same set of steers in the picture that I showed you earlier. This is what it looks like, what the contents look like when they're on tall fescue. It looks a lot like forage, right? And then, but you know, if you've ever worked in a packing plant, or even if you're a deer hunter, you know that it doesn't smell like forage, that it smells like fermentation. They're smelling fermentation acids, acetate, butyrate, you know, these compounds that are in vinegar. And they're really nutritionally important to the animal. The animal can absorb them right through the wall of that rumen. There's no mucus on that. I don't know if you can see my pointer right here, but this is kind of the interior lining of the rumen, and they can wick those fermentation acids right away and bring them into their blood and use them for their nutrition. And that rumen is loaded with microorganisms, and these are just some examples. So basically, the point is that every kind of microorganism you think of, every family of microorganism is in there. There are fungi and bacteria and protozoa and archaea, which most folks are really important, but most folks have never even heard of them. I'll show you this image again on another slide, but this is kind of a beautiful picture that one of my colleagues took of a protist that has some methanogens growing on it. I'll show you that one again in a minute. The bacteria are a really important component to it. So really dense cell growth in the rumen. And so about 1% of the internal volume of the rumen is actually inside bacteria. So if you've got a big old dairy cow with a rumen like a 50-gallon drum, you know, half a gallon is going to be the insides of bacteria. That comes up to about 1 billion cells per milliliter. And so if you had a teaspoon of rumen fluid, there'd be more bacteria in that teaspoon than there are people in the United States. And very diverse. So some estimates indicate as many as 1,500 species, all of them doing different things, making different products and doing things for that animal. And so here's some images that some of my friends have taken, nice electron micrographs, really up close images. The one on the top by Dr. Paul Weimer, he retired recently. He was at the U.S. Dairy Forage Research Center up in Madison. And so these three, I can get my pointer back here if you can see it. These three up here are good guys in the rumen. So these are fibrolytic or cellulitic bacteria, they're called sometimes. And these are the three main species. You can see this one, you can see a fiber right here, a grass fiber. And growing along it, these little pill-shaped structures are actually bacteria that are breaking down that fiber. And that gives the animal metabolic access, nutritional access to fiber, which if you or I were to eat it, mostly goes out the way that it came in. But they can get calories out of that. Over here, down here is this other image that I already showed you. And so that's a protist called Intodinium. The interesting thing about that are these little pill-shaped structures that are plastered along its belly there. They're methanogens. They're the microorganisms that make methane, and they're growing right on that other microorganism, just like barnacles on a ship. And they'll take carbon dioxide and hydrogen and make it into methane. So our goal for the rumen is to get as much of the plant tissue that we can make with sunlight and soil and water, and get the carbon and the nitrogen from that plant tissue into animal tissue, which we can use, which we can sell. That's what we won't need the rumen to help us do. And for the most part, it does it, but there are wasteful processes in the rumen too. It can be optimized. So I mentioned before the methanogens that make methane. Our industries get criticized a lot for the production of methane, which I don't think is exactly fair. Maybe that's a story for another night. But that production of methane does take away carbon that would otherwise be going into animal tissue. And the same thing with nitrogen. And so nitrogen ends up converted into ammonia and then made into urea, and they're going to pee it back out on the pasture or in the feedlot instead of becoming muscle tissue. And the bacteria that carry out that process are called the hyperammonia producing bacteria. You heard Brittany called them the HABs. It's one of the groups that we really watch really carefully when we're doing our experiments, because in general, we like to keep them low. So the idea is that if we can suppress groups of microorganisms like that, if you can keep them down with an antimicrobial, that you can then influence feed efficiency, you can increase feed efficiency, you can increase weight gain. And Brittany's going to show you some data where we've done that. And so this is an analogy I like to do. Bear with me if you've seen it before. But this is a picture of my hayfield. You know, there are good and bad things in hayfield too. And so you can compare the rumen to this other biological system, to a pasture, to a hayfield. And, you know, you have forage species in that hayfield. and they represent the productivity in your pasture. And then you can like take a picture of my poke there by my fence line and think of that as a weed species. And it's using the nutrients in the pasture, but you're not getting anything out of it. Unless you got goats, you know, you're not going to eat that poke. It's no different in the rumen. You can think of these beneficial species like these cellulitic bacteria here as your forage species. And you can think of those methanogens that make the methane carry out the wasteful process as weed species. And if you do that, then your antibiotic growth promoter becomes an herbicide. It's just like an herbicide. It is a mechanism to control the biology, to direct nutritional resources where you want them to go. And so Monensin is a great example of that. Chicken wire there is just a bond line structure of what Monensin looks like. That's just what the chemical looks like. Monensin is an antibiotic. It's a compound made by a microorganism to kill another microorganism. It's actually a really great coccidiostat, and Elanco used it as a coccidiostat first. And then it was repurposed later as growth promoting antibiotic when they figured out that it did that. And Elanco estimates that these are old numbers too, that it saves about 1.4 million tons of feed per year in feed efficiency. And that's really just beef. Really just, we're talking about finishing operations, not including dairies, because it's used in dairies now too. As my graduate advisor, Dr. Jim Russell. And so I like to mention him because he was the one that really figured out how Monensin worked on hyperammonia producing bacteria. You know, we knew that it worked, but he figured out why it worked. And these are just some of his papers that he published that were related to that. And I'm going to tell you how it works because I think it's important to the story that Brittany's going to tell tonight. So what we have here, this diagram right here, is a bacterial cell envelope. I can get my pointer back. Oops, let me go back there. There's my pointer. And so this purple over here is the cell wall, and this is the cell membrane, and that's really the important part. If you think of this is outside of the cell, and this is inside of the cell. And so a membrane, a bacterial membrane, really works a lot like a hydroelectric dam. So, you know, a hydroelectric dam, you've got a concentration of water on one side, and you let it come through, and you capture that power to do work, to generate electricity. It's really the same with a membrane, only it's with ions. And so you have ions, a gradient of ions on the outside of the membrane, and more of them on the outside, fewer of them on the inside. And you can let them go through to do work. You can capture it to do work in exactly the same way that a hydroelectric dam works. And so Monensin works in that way. If again, we have, you know, the outside of the cell over here, and we have all these ions on this side and the inside of the cell over here, and a different type of ions, we show potassium ions over here, they do different things. You have these concentration gradients that can do work. And you add Monensin and it pokes holes in the dam. And the membrane ends up depolarized. You end up with the same concentration of ions on one side of the membrane as on the other side of the membrane. Same amount of water on both sides of the dam. You're not going to generate any power like that. So that's how Monensin works. There are other classes of antibiotic growth promoters, macrolides like Tylan and tetracyclines like CTC. And we have other reasons, you know, that we give those. We give them to prevent infection, to prevent liver abscesses. When you're feeding a lot of grain, it's a good reason to give Tylan. And Monensin is an ionophore. We have other ionophores like lasalicid. And basically, we can get growth promotion and feed efficiency with all of these, even though we're not allowed by the veterinary feed directive to give them for those reasons now. But it doesn't mean we should give up on growth promotion. They tend to be very broad spectrum, and they'll tend to kill the good bacteria as well as the bad bacteria. And they're most useful in starch-based diets because you don't need the rumen as much in a starch-based diet. Actually, the rumen becomes a liability if you're going to feed a lot of grain. It's very useful on a forage diet because you need to get calories out of the fiber, but the animal can utilize starch just fine without the activity of the rumen. And so the spectrum of activity is pretty broad. Isoflavones, including biocanin A, work in a different way. And so I'm going to show you that membrane again. In this case, so we have a cell membrane of one species, And you have to imagine it being in the rumen where it's surrounded by many other bacteria of other species. And so here's one over here, a different kind. And it might release an antimicrobial, a rumen native antimicrobial, to poison its neighbor, because it can get resources from its neighbor if it does that. So chemical warfare among bacteria. But that neighbor might develop a pump to pump it out. And so it's using the proton motive force that we talked about before to pump that poisonous peptide, whatever that compound is, right out. And so it's not inhibited. But that's my isoflavone right there. That's kind of what one looks like chemically. And so if you add the isoflavones, they interfere with those drug efflux pumps. They block the drug efflux pumps. And then you can have those other compounds that are made in the rumen by other bacteria. They can accumulate, and it'll make that bacterium sensitive, even though it wasn't originally. And so that's the way that biocanon A and the isoflavones work, is by increasing the effectiveness of other compounds that are already there by blocking pumps. We did a lot of work in the laboratory before we get to what Brittany's going to share with you tonight. And I'm not going to go through it all and bore you to tears, but I just want to show you that we did do our homework. And these are all published references of the many effects that we've seen. And so we tested this thing every which way to Sunday before we went to the field. We think that's really important because we want to use resources well. You know, animal experiments are expensive, and we have to be really selective about the ones that we do. We want to be careful about them. And so we make sure that something works in the laboratory before we bother to test it in the field. So to come back to the big picture a little bit, you know, after you've heard Brittany's talk, or maybe you've heard other talks that we've given, you know, I've had folks say to me, you know, Flythe, you mean you're trying to tell me that we can replace ractopamine, Tylan, Rumensin, chlorotetracycline, estrogen implants, anything else you name it, we can replace these with feed? And I would submit to you that if you ask that question that way, you're looking at it backwards. That, like I said, we don't know what we don't know. And the fact of the matter is we haven't always understood the nutritional importance of all these other compounds, these secondary compounds in the feed, and what our animals really need. And so because of that, we've made up for those inefficiencies with all these drugs. So considering, many of you use forage legumes or supplemental legumes in your systems, and, considering all that you know about them, and I know you understand their agronomic value, but along with that, the information that we present to you today, and Brittany's going to present to you today, I kind of pose this question to you. Do forage legumes fit into the value system that I set out at the beginning? You know, I like to think that they do. The low nitrogen inputs, low nitrogen inputs, you know, not needing to put nitrogen fertilizer on the same way if you use legumes. The pasture quality, high protein digestibility, the addition of forage diversity, and in terms of the impact of diversity on soil health is another thing that we really, don't really fully appreciate yet. And the improved animal performance that you get from some of the things that we're talking about here tonight. It's just, I'd like you to consider those. One more concept, I think, because it's actually in Brittany's title, that I wanted to share with you. It's something that, when, we're eating lunch, when we're drinking coffee, when we're thinking about how to think about our research, it's something that, she and I and Glenn before he left, and all of our researchers, it's one of the things that we've been chewing on. This idea of a functional feed, kind of challenging the way that we think about nutrition. And so the term is borrowed from a human nutrition concept, functional food, the idea that a food has a benefit beyond what we traditionally consider nutrition, or the idea of food as medicine. And you can probably think of a lot of feeds that fit into these categories. A plant that doesn't have to be extracted, something that the animal can graze, something that's in forage, or a plant that could be used as a forage plant. So not necessarily something you would buy in a bag. Although, it comes to clovers, there are some folks that, I talked to folks out in southern Missouri where they don't have any phosphorus in their soil, and buying something in a bag sounds really pretty good to them. So I don't want to be too hard on that solution. But for many of us, we can grow clovers. We'll be able to grow these functional feeds. That's the idea, that things you could produce yourself. And it considers the evolutionary history of the animal and the natural grazing and browsing behaviors of the animal. That's not just good for production, it's good for the animal's health. You can't argue that an animal that is vasorelaxed is in better condition than an animal that's vasoconstricted. And it ties in with the idea of pasture plant diversity contributing to soil health, which is related to this huge nitrogen problem that we have in terms of land and water use, and even the water and drought problems. And so that kind of comes back to this idea that I think the type of agriculture that we practice here in Kentucky is good. I think that other parts of the world have things to learn from us. And so with that, I will stop.
Well, it's a great overview, Dr. Flythe, of all the activities that your group has been working on. And I just want to remind everybody that if you've got questions, feel free to type those into the chat box. And Dr. Flythe will be hanging on this evening with us, and he'll take those questions as we go through the rest of the presentation. But think about those things that he mentioned, and some interesting ideas there that perhaps we haven't really given a lot of credit to, is that functional aspect of those compounds in clovers. And that's just one species. There may be other things and other forages that we may find in the future to help combat some of these issues.
Yes, sir. Absolutely.
So who knows, maybe that kudzu on the roadside may be our next best friend. So at this point, I'm going to introduce Dr. Brittany Harlow. Dr. Harlow received her undergraduate at the University of Illinois, and then completed her PhD in animal and food sciences here at UK. She then carried on as a postdoc with USDA, and Brittany now is a research scientist with USDA and the Forage-Animal Production Research Unit here at UK. She's done a lot of work in the microbiology area, and actually Dr. Harlow's work was tied back into the equine industry as well. So she has both a ruminant background as well as an equine background. So with that, I'm going to turn the program over to Dr. Harlow, and she's sharing her screen now. So Dr. Harlow, take it away.
Thank you, Jeff. I just want to say again, like Michael had conveyed to you guys, that we really appreciate this opportunity and our relationship with the University of Kentucky to be able to share some of our research through your extension channels. So today, I think I have the easy job. Michael had to give all the background, but I get to just talk about the hard research. So bear with me. There's a little bit of background that repeats what Michael had to say, but we'll try to get to the meat of it.
Sometimes you got to go to the bottom left. There you go.
Okay, so back to this red clover concept. So Michael introduced to you guys a little bit about antimicrobial growth promoters. So when we're talking about that, we're talking about Rumensin or Bovatec, which all of you are probably very familiar with. So when we think about antimicrobial growth promoters and developing new antimicrobial growth promoters, we're looking for an antibiotic or another antibacterial compound that will selectively kill certain bacteria in the rumen. So like Michael had explained how Rumensin works. It then alters how nutrients are utilized, so it shuts down methane production or hyperammonia producing bacteria and protein wasting, and then it allows the ruminant animal to gain more weight or improve their feed efficiency. So one of the primary targets of antimicrobial growth promoters that are on the market is protein utilization. So I'm going to kind of skip through this quickly since we already talked about it. So there are hyperammonia producing bacteria in the rumen that when an animal consumes protein, they'll utilize that protein, proliferate, and then they'll waste it out through the urine with the production of ammonia. And so antimicrobial growth promoters like Monensin go ahead and kill those bacteria and allow it to go through to enzymatic digestion in the stomach, and so the animal can actually utilize it. So Michael introduced the concept of beneficial species and wasteful species, but another consideration when we think about antimicrobial growth promoters is what does it do to beneficial species? And so we know that obviously the rumen is extremely important when it comes down to fiber utilization, as Michael had introduced. But a lot of antimicrobial growth promoters like monensin actually can inhibit fiber fermentation while they have a lot of other benefits. So when you look at kind of a pooled, table of studies that have been done looking at things like rumensin and grazing animals in different states and different grazing systems, you often see kind of a variety of responses. Sometimes you see a lot of benefit, sometimes you don't see any benefit from control, and sometimes you actually see a negative effect. And I think that relates to the importance of forage in those systems and the use of that fiber. So what really sets Biocannon A apart, or isoflavones from red clover, again, we'll use those interchangeably, is that Biocannon A in the pasture in that red clover inhibits protein utilization with killing off those AJBs, as we talked about, just like monensin, but it actually improves fiber utilization and doesn't kill those bacteria because its mechanism of action is different. This in turn improves the production of different energetic end products in the rumen that we would suppose would probably lead to an increased performance. And so that's really what I'm going to be talking about today, is how that links to performance benefits. So the first question we wanted to ask in the field was, does it work? So Dr. Aiken, my predecessor, and Michael came up with this idea to go ahead and try this out in a grazing system. And so what they did is they had 3 treatments. They had a pasture-only control, they had a pasture with supplemented dried distillers grains. And you'll note through this talk, we use a lot of dried distillers grains because they don't have any isoflavones in them, unlike something like soybean meal. And then there was a treatment that was dried distillers grains plus Biocannon A, so the same amount of protein as the other dried distillers grains treatment. And what we saw was that the addition of just 6 grams of Biocannon A, top dressed over the feed, added a ½ pound of gain per day. And so, yes, extremely effective at improving gain, probably due to those ruminal activities. But Biocannon A as a purified form is extremely expensive. So let's take it back to what we can do in our production systems that would be, economically relevant. So the first thing that we decided to look at, and to control level really, was supplementing red clover hay. So whole red clover hay that has all the different isoflavones in it, including Biocannon A. And so we used 2 different levels in this study of 15% and 30% red clover. And then again, we had a dried distillers grain control. And all of these treatments were made to be equal for protein. So the 15 and 30% treatment were only different because part of it was red clover, that protein. What we saw was that we saw a reduction in hyperammonia producing bacteria in the rumens of those animals, improved fiber digestibility, and then that translated to improved average daily gain. So on the 30% treatment, we saw about a 2/3 pound per day improvement over the dried distillers grain control. But in the 15% treatment, which was really interesting and unexpected, we actually saw an improvement of over a pound per day in those animals. And this kind of indicated to us that maybe there's some kind of lower concentration that might be more effective. So another question that came up in these studies or in talking to producers was, what about different quality pastures? What if, in low quality pastures where we don't have, sufficient stocking to keep our pastures grazed down, maybe it's going to be more effective because it improves fiber utilization, and fiber is even more important in low quality pastures. And what we found was by supplementing red clover hay, we were able to improve average daily gain over a protein match control in both the high quality and low quality pasture systems. And what we saw was an improvement of about the same in both of those different pasture grazing treatments. But what I thought was probably most notable is that we saw an improvement to 2.1 pounds per day in the low quality treatment with red clover. And that was actually equivalent to the high quality grazing control. So something as simple as just supplementing in 50% of their protein supplement as red clover hay can improve, make up for that difference in pasture quality, which I think is pretty significant. So what about, we spent a lot of time here talking about pasture raised cattle, but when we think about Monensin and other feed antimicrobials, we usually think of them in grain finishing systems. Is there any application of these, red clover derived phytochemicals in grain finishing? So as I had just mentioned, we see a lot of these antimicrobials in feedlots and other systems that require high concentrate diets. And that's a lot to do with the fact that they're just more effective when you remove fiber from the equation or decrease the importance of fiber in the equation for generating that energy. So with the veterinary feed directive, this is more highly regulated. And so we're looking at antibiotic alternatives of interest. And so we wanted to see, can Biocanon A be utilized in these systems like Monensin? So a common problem that occurs in these feedlots is called subacute ruminal acidosis. And I'm sure many of you guys have heard about that. Essentially what happens is the animal consumes a bunch of concentrate, those 90% concentrate diets or 70% concentrate diets, and their rumen has reduced pH, and that kills off a lot of existing fiber utilizing bacteria. And it also allows bacteria that ferment starch to grow, a lot of them. And so you see this reduction in pH, which can lead to a bunch of other health consequences in the body and production losses. So Monensin is pretty commonly utilized in feedlot systems to combat SARA. And so when we challenged steers in a study with SARA, what we found was that Monensin was able to improve pH as we would expect. It decreased the bacteria that ferment starch, which again is good for modulating those rumen effects. It improved fiber utilization and also hay digestibility. When we put that side by side with our Biocanon A treatment, surprisingly, we saw that an even greater improvement in all of these characteristics, a greater mitigation of SARA. And so I just think this is a really great example of a production system that isn't based on forage, but look how much it can be improved by adding one single ingredient that's present in a forage diet. So something to think about moving forward. So again, Michael covered a lot of this background, so I don't want to get too deep into it, but again, we're going to switch gears a little bit, and we're going to talk about fescue toxicosis. And Michael already talked to you about vasoconstriction related to fescue toxicosis and the several, the many different ugly symptoms that can occur, ranging from a little bit of performance loss that you might not notice on your farm to, loss of tail switches or fescue foot when the hooves actually can fall off. So ranges of severity. So I really like this slide, and Michael already explained it, but I have a new kind of thought, a way that I'm looking at vasoconstriction and vasorelaxation that I'd like to share with you. So when I think about vasoconstriction and vasorelaxation, one way to look at it is to think of it as a straw. So he was saying, it looks like you're staring down the barrel of a gun. And when you look at those two pictures of vasoconstriction and vasorelaxation, you might not think they look that different, but essentially what you're talking about is vasoconstricted animals have an artery about the size of a coffee stir, while vasodilated animals or regular animals have an artery the size of a milkshake straw. So if, a waiter came to your table and brought you that really delicious Oreo milkshake there that I'd like to have right now, and offered you either a coffee stir or a milkshake straw, which one would you choose? And can you imagine, if an animal who normally has an artery the size of a milkshake straw is vasoconstricted, how little blood is able to go to those extremities, is able to feed into those peripheral tissues and transport nutrients where they need to go, and how hard the heart is working to move the blood around. But I think this is just a really good illustration of what's happening there, because it actually is relevant size-wise. So if you're like me, I want 2 big milkshake straws when I'm drinking my milkshake. And part of that is what we think about when we think about isoflavones too, is, maybe we can get some increased vasodilation above normal. So Michael showed in his goat study, in some cases, but the isoflavone treatment, there was actually an even above baseline impact of those isoflavones on the arteries. So that's the goal. So taking Michael's study and demonstration that isoflavones can alleviate vasoconstriction to the field, the first step was looking at something that we all are familiar with, in Kentucky at least, and that's interseeding clovers into our tall fescue stands. So in this study, what Dr. Aiken did is he had two treatments. He had endophyte infected tall fescue as a control, and then he had an endophyte infected tall fescue pastures that were interseeded to have about a 30% stand of red clover in them. And it's important to note that he did apply fertilizer to the endophyte infected tall fescue pasture controls. And so they actually were really similar in nitrogen concentrations available with grazing. And what he found was that the red clover consuming animals had greater vasodilation and also had improved average daily gain of about a pound more versus the controls per day. So what if we go a little bit lower? So we talked about how lower levels worked better on non-toxic pastures, or can we use lower levels in this fescue toxicosis, application? And so we looked at 15 and 30% red clover supplementation. And again, everything was matched for protein using dry distiller sprays. And what we found was that both levels were able to improve vasodilation and improve average daily gain. So one of the common questions when we present this, historically has been, can we use other legume sources to elicit the same benefits on our clover pasture or on our endophyte infected tall fescue pastures? I have white clover in my pasture. I might have soybean meal that I mixed into my feed already. Does that work? So we went back to the pens with the goats again, and we looked at 3 different treatments: red clover, white clover, and soybean meal, all at the same weight. And what we found was that regardless of differences, all of these sources cause vasodilation. And so what's really interesting about this is that these different isoflavone sources all vary in concentration, but also in composition. So red clover and white clover are pretty similar in their composition of isoflavones, but white clover is about 200 times less isoflavones, so way, way lower, which indicates that maybe lower levels could be utilized than we could even have imagined to be able to alleviate this vasoconstriction. So how low can we go? So for this portion of the study, we did the math and we realized that the amount of red clover we would need to beat the white clover treatment was essentially what would fit in the palm of your hand a day. And so we talked with Berkman Nutrition and we said, can we mix this in a conventional loose mineral? This is something that producers might be able to utilize, if they can establish red clover in their pasture or if they want to use a different supplementation strategy. They said, yeah, let's do it. So we mixed up some red clover tissue and mineral. We had 3 treatments, a 20% red clover treatment, which was similar to our white clover treatment in the previous study, a 15%, a 10%, and then a 0% control. And what we found was that with 0% red clover, so just our control animals, when they were challenged with fescue seed, we saw constriction, as we would have expected with tall fescue toxicosis. And when we added any level of clover, we saw an improvement in vasodilation. And this was just really impressive that something as small as a handful, something that could be found in almost any pasture, could alleviate vasoconstriction. So generally, all mineral treatments worked, and 20% was actually most effective. So changing gears a little bit, I've spent a lot of time talking about stocker research that we've done in this as part of our unit, but we're also interested in other categories of animals. And as you all know, Kentucky is a pretty large beef cow-calf state. And so we do have some interest in that. And so I'm going to share with you a few studies that relate to cows. So the first study I'm going to share with you is something that I think is a really great illustration of some of our partnerships. And so in this study, it was looking at adding value to market cows. And this was a study that was a collaboration between our ARS unit and Kentucky Beef Network and their Beef Solutions program. And a lot of you are probably familiar with it, have seen this Kentucky ground beef on the shelves at Kroger. And so we did this study at Eden Shell Farm. And essentially what they did is they purchased, market cows from the stockyards, and we subjected them to 3 different grazing treatments. And it was just a short window of grazing, a couple months. And so one treatment was hot tall fescue control. So they didn't have any supplementation aside from that. The second treatment was a 30% red clover interseeding treatment. So something kind of similar to what we used in the stocker study. And then the last treatment was a Chaparral treatment, and some of you may be familiar with this. It was produced by Dow AgroSciences, which is now Corteva AgroSciences. And this is kind of an interesting herbicide in that it has aminopyrrolate as a for broadleaf weed control, but it also has a secondary ingredient, metsulfuron. And what is most interesting about metsulfuron is it's a plant growth regulator. And so in our case, we're really interested in it because it will actually decrease the emergence of seed heads on tall fescue, which makes the pasture generally more vegetative, higher nutritive quality, but also ergot alkaloids that cause tall fescue are concentrated in seed heads. So by decreasing their emergence, we can decrease the toxicity of the pasture. And it turned out that both these treatments, 30% red clover treatment and the Chaparral treatment, were extremely beneficial at improving the productivity of these animals. So we did this in 2018 and 2019. And over both years, we saw an increased value of about $117 per head in the first year and $192 per head over that 63-day grazing window. The cows were gaining about 2.3 pounds in the first year and 1.6 pounds per day in the second year. And in both years, about a pound in body condition score was added. And that's pretty substantial when you think about taking some market cows just straight from the stockyards and putting them on pasture. So really interesting results there, thinking about a different group of animals that are important to us Kentuckians. So another question that we get a lot is, well, isoflavones, we didn't really talk about it, but they're phytoestrogens. So what about our breeding herds? Can we give these to our developing heifers? Can we give this to our cow herd? Where do the losses meet with the benefits? Can we expect reproductive failures? And so we decided to address this again with one of our great partnerships, again with Kentucky Beef Network and Berkman Nutrition for the mineral, and then Dr. Les Anderson with the University of Kentucky, as you all probably know him pretty well, did a lot of the reproductive measures related to this study. And so this study we conducted at Eden Shell Farm 2 with beef heifers from their resident herd that were grazing endophyte infected tall fescue pastures. We have two treatments in the study. We have a conventional mineral and then a mineral that has 20% red clover leaf. So similar to what those animals were getting in the pens where we saw the vasodilatory response. So as part of this study, we're looking at, reproductive rates, conception rate, obviously, but we're also looking at things like heat stress. And so some of you may have heard about Dr. Anderson's cow manager tags. He's implementing use of them in several different farms and at the University of Kentucky herd. And those are really interesting because you can actually monitor a lot of different characteristics about the animal, like their cycling, but also their activity. And so we use those tags, or we're trying to use those tags to look at heat stress in these animals. And we're also looking at mineral consumption so we can get a little better idea of that field. But stay tuned. I don't have any results to share with you about that today, except for nothing's looking bad. But hopefully we'll be able to share that with you in the future. So I don't really have anything else to share, and I hope I didn't go too long, but me and Michael would be glad to take any questions if there's time.
Thank you, Dr. Harlow. That was a great overview of some of the more applied approaches on the research, taking kind of that basic science and taking it to the field level. We always appreciate seeing that. And it kind of brought up a question here from Mr. Yoder, and Michael typed it in, but I'll go ahead and repeat it, Michael, and you can give your answer to those that may be on a phone that can't see it as easy. But the question was with regards to the first goat study, where you were looking at adding, I believe it was straight biocannon A when you were feeding the seed, and the response in vasoconstriction in those goats.
Yeah, that's right, Jeff. Clover is an entire plant. There's protein. There's other nutrients that are in it, and you have to be able to separate out those effects. And so while it doesn't look like farming, it clearly looks like research. You got to start at a point where you're using purified compounds so you understand how they work. And that's why research is such a long, protracted process. Because before we can get to the types of experiments that Brittany showed you, we have to do some stuff that's impractical first, just to understand the mechanism. But I hope that some of those later experiments that Brittany showed you meant something to you, because they're more like farming.
I wanted to follow up with that work, Brittany, because, you know, when you mentioned 15% in some of the stocker work, is it safe to say that we're just looking at maybe a couple pounds of red clover hay on a 6-weight calf?
Exactly. So I think in that study, the first year, based on isoflavone concentration, it was like a little over 2 pounds per head per day. And I think we used like 650 pounds as our weight calculation. And on the second year, we had really, really high isoflavone red clover hay for whatever reason, which we're still learning about too, what influences those levels. And it was almost 1.5 pounds per head per day. So there's some real utility in small quantities for these compounds.
You know, it's interesting. We've kind of maybe did a 180 on our outlook on some of these isoflavones. Early research, particularly in I think maybe New Zealand and maybe Australia, the work was more concerned about phytoestrogens having a negative impact on reproductive issues in cows. So, Brittany, I know it's a little bit early in the work, but why have we kind of thought of this maybe differently now?
I think it depends on the level of supplementation that we're talking about. So in this study, you know, that we're doing at Eden Shale right now, we're really testing the application of mineral. So we're talking about a handful of red clover, something that, you know, you might find enough white clover in any central Kentucky pasture to have that amount of red clover. So I think that's why we would anticipate there would be little to no reproductive issues related to that treatment. In conversely, you know, we expect that there might be some benefits. You know, we might see some alleviation of vasoconstriction in those heifers. They may have an easier time letting down milk. We might actually see increased fertility rates, or we might see increased heat tolerance. And so that's why we're looking at a lot of different measures in that study. I don't think, you know, that experiment necessarily would represent higher levels of red clover in the diet, but that's something that we probably need to look into for a kind of a cost benefit type of analysis. So what are we losing in terms of reproductive function versus what are we gaining in terms of health, and how does that all balance out?
And I think that's also another thing that we can sometimes don't consider. If I remember right too, those probably was subterranean clover or maybe even a different clover species, and there may be different isoflavone concentrations like you guys mentioned. So it could be that there's just a different proportion of those isoflavones that have a maybe more binding affinity or have a bigger potential impact on the negative aspect of things. I don't know. Go ahead.
No, this is Kevin in Princeton. I've got a question for Brittany and Michael. Are we putting the wrong additive in our free choice mineral for grazing stocker calves on dirty fescue? Should we pull the Rumensin and put some? Is there any way to put a cost-effective isoflavone compound in a free choice mineral at this time? That's, you know, or do we put both?
You want to take that, Brittany?
You can go first, Michael, and I'll follow up.
It's one of the problems with putting red clover tissue, and Brittany, I wish Tracy was here, because he's the one that's been extracting it. And by I say extracting it, I mean that, you know, he takes hay and beats it out over a screen until you get leaf tissue, and then ground up the leaf tissue. It's a very light extraction, but that stuff is really light and it takes up a lot of space. And so over the long run, I don't know whether, you know, mixing the way that we're doing it probably isn't the way that it would work. And so do we need to synthesize it is the question. And that's we've discussed that with some of our friends, and it might be something we do in the future. When it comes to, you know, the amount that you need on pasture, you know, to reverse vasodilation, Brittany's research has shown us that it doesn't really matter how much you have. And so really probably what you need to think of are the agronomic concerns, not the animal ones. The question is if you put them out there and you think you're going to leave them out there for 30 days and they have it all grazed out in 2 days, it's not going to help you.
Can I follow up there? What about alfalfa? It's easier to find alfalfa hay to buy and purchase from a practical standpoint than to find pure red clover hay. Is that the mystery growth factor of alfalfa that Dr. Burris likes to talk about? They used to talk about a long time ago, would it help to just put a bale or so of alfalfa every day to our grazing calves? I mean, that sounds crazy, but.
Well, we've looked at alfalfa a little bit.
I mean, what do y'all think?
We looked at alfalfa a little bit in the lab, and we don't have, or at least I don't think we're ready to talk about yet any field experiments yet, Brittany, but we've looked at it a little bit in the lab. And the problem is it makes different members of that family of isoflavones. And so it does make some of the same ones in really, really low concentrations, and it makes other things. And if we could get a plant that had the chemical profile of red clover and the taproot of alfalfa, we would really have something, you know what I mean? But for all the advantages of alfalfa, I don't think this is going to be one, but more to come on that.
Brittany, I think your presentation maybe also goes back to a little bit of answering Kevin's question, and maybe our mindset isn't as much as an additive, but maybe interseeding.
Yeah, certainly. I mean, Glenn's work with interseeding was, just glaringly obvious how beneficial that was. And luckily, in most of Central Kentucky, we have a pretty good chance of throwing some frost seeding out there and getting some growth back. So that's probably the number one easiest application that people can do. Certainly. So definitely would suggest that. And if you can't, that's why we're looking to other options, thinking about red clover hay, thinking about other legume sources. So for the fescue applications, it seems like that could be really, utilized, application of soybean meal or other legumes.
Soybean hulls.
Yeah, soy hulls. We have some research in that indicates that the isoflavones impart some pretty significant growth benefits.
So Jeff, you and Katie will be shocked to hear me say that it was actually a really good nutrition talk tonight. How about that? So appreciate it, guys. My question has to go along the lines of, because we had Dr. J.D. Green on a couple of months ago, and when talking about weed control and everything else, and one of the adverse effects of that is you usually wipe your clover out as well. So at some point in time, it looks to me like we're going to have to maybe rethink what we're doing there a little bit. Maybe tolerate some weeds because of the added benefit from the clover. I know that might be a little further down the road, but any thoughts on that?
It's a tough decision, Darren, and it's every farm is different, and probably every pasture and every hayfield and every farm is a little bit different, in making those decisions. But it is certainly a consideration. With red clover, which is one of our favorites, eventually you're going to have to reseed it anyway. It's not going to stay there forever like where white clover is. It's not a true perennial, and unless you have a hayfield like mine, I never put enough nitrogen on it, and that seems to be an advantage to the red clover, and it comes back year after year, but it really isn't a perennial. And particularly if you get poisonous weeds out there, or something that's really taking over and hurting your forage yield, it might be worth it to you to take the clovers out and then replant. So that's one of those many management decisions. Unfortunately, that's the downside of research, is the more information that you give to the farmers, the more they have to know, right? And since there's no silver bullet, we're asking you to know one more thing and one more thing every year.
And I'd like to add, that companies, these producers of, herbicides and things are working towards getting some herbicides in there that allow clovers to, remain in your pasture, as a more neutral type of herbicide, or a less damaging herbicide to your clovers. And I can't really speak to specific projects, but I know I've heard a lot of whispers and talk about that coming around then too. So those might be some options for our producers.
Brittany, this is Katie Van Valen. So my question may be a little irrelevant because you guys have talked about how the future of this work may not include putting clover directly in the mineral. But have you all been able to look at mineral intake into any of those treatments?
Yes, ma'am. And I don't know if you remember, but I bugged you about this when we started because you indicated and taught me that we were supposed to look at dry matter intake specifically and so on and so forth. And we have been doing that. And I can't speak to the exact concentrations of intake per day, but they are very similar to the conventional mineral controls. And we had done an intake study prior to the start of our pen study with the clover mineral. And as you saw in the picture, it looks like feed. You know, it really does. But they did not eat it like feed. They got down to about 5 to 6 ounces per head per day, and that was pretty similar to the commercially available control.
Again, just as a reminder, if anybody's got any questions, you can type those into the chat box. Dr. Bullock has put up the Cape code there as USDA beef for those of you that were wanting or needing Cape educational requirements. You know, I think this work opens itself up to a lot of could it, what ifs, and I think that's exciting. You know, I sit here and think about the feedlot section of our industry and how they sometimes struggle getting fescue cattle started on feed, and that during some of the warmer months because of that vasal constriction. And maybe rather than using alfalfa hay in those receiving rations and startup rations, if they used red clover hay, could that not help manage these fescue cattle and get them through that receiving period a little bit better? So there's a lot of what ifs, and I'm really excited to see where this work goes in the future. And if it's, you know, something as simple as a little bit of orchard grass and red clover hay, yeah, we can get that pretty easily. Or if it's a little bit of soybean meal, we can do that pretty easily as well. So I think what you all are doing has great application to the beef industry. Any other questions that anybody has? There's a question that came in regarding managing cover crops. Let's see, trying to see here. Sayer, managing cover crops for profitability. Chelsea, I'm not 100% sure if maybe that is thinking about alternative options for funding, is to think about using maybe some cover crop potential money as a way to fund some reseeding or seeding there. And Dr. Bullock just mentioned too, check with your county agent on Cape educational requirements. Dr. Flythe, Dr. Harlow, any closing comments that you all would like to share?
Once again, we just really appreciate you having us out. The research means a lot to us. Kentucky agriculture means a lot to us, and you know, we're part of a big team here, and we're really happy to be part of the program.
Exactly. We're just really thankful for our collaboration with UK and having this opportunity to share some research. So thank you so much for letting us talk today.
Well, we sure appreciate you all coming on, and it's been a great evening. And, you know, you held the crowd. They were all here to the very end. So great information. And like Dr. Bullock said, sorry, Dr. Van Valen, this is probably one of our better nutrition discussions that we've had, because it has a lot of application. And, you know, it really is something that we can go back out there and say, you know, it's not just dilution is the solution to pollution. There are other things that are going on here. And it seems like it has a great opportunity to make some improvements. So with that, I'm going to bid you all a farewell, and we look forward to seeing you all again here in December. And if you have any questions, feel free to reach out to us. Thank you all.